pleasure to be here today. I'm Amy Hare. I'm Assistant Professor of Pediatrics at Baylor College of Medicine, Texas Children's Hospital. I'm also Program Director of Neonatal Nutrition, and I run our intestinal rehab team in the NICU. And today I'm going to be talking to you about achieving optimal growth for very low birth weight infants while improving outcomes with an exclusive human milk-based diet. My disclosures: I do receive research support from Prolacta Bioscience for 2 ongoing studies. One, I am the coordinating PI for the human milk cream study, and I am part of the human milk cardiac study. I currently do not give any talks for any companies, and I will not use any off-label discussion use or investigational use of products in my presentation. Just to tell you a little bit about the unit that I take care of back home in Houston, Texas, where, yes, guys, it did snow 3 days ago, or maybe it was 4 days ago now. So the last time that happened was 8 or 9 years ago. Anyways, we have a 175-bed NICU. It's comprised of a level 4 NICU, a level 2 NICU, and then we have our inborn unit at the Pavilion for Women. So I have the pleasure of being responsible for nutrition and practices for all these little babies. And to talk about the objectives today, I'm going to start off with some of the science of human milk and breast milk and talk about an exclusive human milk-based diet as it relates to preterm infants. I'm going to talk about recently published literature regarding growth of infants receiving all human milk diet and a bovine-based diet. And I'm going to talk about some strategies to promote adequate growth of infants receiving an all human milk diet. And then I'm excited to share some future directions and research on the use of human milk. So to start off with, I think we can all agree that human milk is best for babies. It's a complex tissue, and I think part of this is that we don't even have the technology to test all the components of human milk. That's my personal opinion. But as you can see here, human milk is made up of, there's living cells, hormones, enzymes, transporters, cytokines, immune modulators, growth factors, and of course, nutrients. And the nutritional components of human milk, there's macronutrients, there's also micronutrients. So when you're looking at carbohydrates, the main carbohydrates are lactose, glucose, galactose, and then we'll talk a little bit about oligosaccharides. You have proteins, various fatty acids, and then as you can see here, minerals and vitamins. And part of the reason I like this slide is that it's colorful, but it also depicts the non-nutritional components of human milk. So again, this I think as each month goes by, there's more science published on human milk and its components. But here we have multiple antimicrobial components. We can't forget the digestive enzymes, for instance, bile salt stimulating lipase, which is often not present in pasteurized donor human milk. There's growth hormones, transporters, anti-inflammatory factors, and other hormones. And I wanted to bring up today certain components of human milk that are getting more attention in research and the literature. So milk fat globule membranes, or the milk fat globule. So this has come to light. As you can see here in this picture, this is a complex structure. So this is taking us back to biochemistry or cell biology. This is a phospholipid bilayer. And as you can see here, these little different components here, like this is glycolipids, and these are glycosylated proteins, and these are all individual components on the membrane of this human milk fat globule that interact with the baby's immune system, intestine, and it's a rich source of bacterial and viral ligands. And so there's thought looking into more research of this particular globule. How can this help premature babies, and how does this work in the body? Another thing I want to bring up, human milk oligosaccharides. So essentially, these are components, they're essentially carbohydrates of human milk that are, for instance, these are fucosylated, or their structure is a certain way that they're meant to interact with the intestinal cells and the immune system in the gut. And so this one, for instance, called 2FL, is being used by some companies and products, and there's also a recombinant form. So basically taking components of human milk and figuring out what they do, and then how can this be replicated to help babies.